All right, so now we're going to factor trinomials where your leading coefficient isn't 1. All right, so this page just says choose a strategy to factor a polynomial completely. So step 1 never changes, okay? If you have a greatest common factor, always, always, always factor it out, okay? Step 2, if it's a binomial, trinomial, or there are more than 3 terms, that's what you want to ask yourself. Is it a binomial? Is it a trinomial? Or are there more than 3 terms, okay? If it's a binomial, right now we have not discussed how to do that. We're going to do that maybe in this video, definitely in the next one. So then it says if it's a trinomial, undo FOIL, okay? If it has 3 or more than 3 terms, use the grouping method. All right, so let's take a look at some and decide the best method. All right, so on this first one, there is a greatest common factor. We can pull out a 6 out of both of these. So we would factor out the GCF first, and then beyond that, we don't really have a method yet, okay? And on the second one, we would undo FOIL. And on this third one, we would do grouping, because there's more than 3 terms. All right, so remember what step 1 was? Step 1 says if there is a GCF, factor it out. Okay, so notice all 3 of these terms are even. If they're even numbers, what does that mean? It means we can at least pull out a 2 for sure, and I know that I can't pull anything bigger than a 2 because that number right there, right? Can't pull a 4 out of a 2. All right. So we're going to factor out the 2 first. So pulling a 2 out. Now, I want to look at each piece and divide by 2. This divided by 2 is just n squared, okay? Negative 8n divided by 2 is minus 4n. And then negative 42 divided by 2 is minus 21, okay? And right now, this is all we know how to do, okay? Oh, no, that's a lie. In that last section, I taught you how to factor something with a leading coefficient of 1, right? Okay, so let's see if this thing is factorable. It may or may not be. Let's do that, though. 1 times negative 21, let's write that off to the side, is negative 21, okay? Do I have pairs of factors of negative 21 that add up to be negative 4? I think I might. But just a reminder, a refresher, if you will, from yesterday, let's write all of them down. Okay, that's all of them, right? Is there one of these that adds up to be negative 4? Yup, right here. Okay, so we're going to, our 2, by the way, has to sit out front this whole time. It never gets to go away. If we were in class, I would jokingly tell you that that's your little annoying brother or sister that follows you around everywhere. Because hopefully, just to remind you to remember to put that 2 there. It's going to be the annoying thing that follows you around, okay? And so now this right here factors to be these 2 terms. All right, so it would be n plus 3 and n minus 7. All right, we did it. We factored. Now, how would you multiply this back out if you were checking your work? Well, here's what I would do. I would do 2 times this, get that product, okay? Multiply this out. Distribute this first. Once you have that product, which would be 2n plus 6, take that product and multiply times this, okay? All right, let's take a look at this one. Okay, so look, they are all even numbers again, so I know I can pull at least a 2 out, but I need to ask myself, can I pull a 4 out of all of these? Well, I can there for sure. I can there, and then 56 divided by 4 is 14. So yeah, I can actually factor out a 4 on this. So let's do that. So 4, and then what times 4 would give me 4y squared? Y squared. What times 4 would give me minus 36y, and that's a minus 9y. And then what times 4 would give me a positive 56, and that is plus 14. Okay, So now let's see if this polynomial is factorable. Again, this 4 is just going to follow us around till the very end. But let's see if this is factorable. So I've got a 1 and I've got a positive 14. I'm going to write that off to the side. And my pairs of factors that multiply to be 14 are 1 and 14, negative 1, negative 14, 2 and 7, and negative 2, negative 7. Is there a pair that add up to be negative 9? And that answer is, yep, this one. Okay? So I know that this right here factors to be these two things. All right, so again, the 4 follows us along for the ride, stays there, and then I've got y minus 2 and y minus 7. There we go. We're done. All right, let's take a look at this one. So do these three terms have anything in common? Yeah, they all have a 4 in common, right? But look, they also have at least one u in common. Remember, I can't pull 2 or 3 u's out of this one, so I can only pull 1 u out, all right? So I'm going to factor out a 4 and a u out of all of these, okay? And what times 4u would give me 4u to the third power? Well, that's u squared. What times 4u would give me 16u squared plus 4u? And what times 4u would give you minus 20u? And that's a minus 5, okay? Now, again, let's see if this is factorable, okay? So 1 times negative 5 gives me negative 5 is what I'm writing here off to the side. Let's write down all the pairs of factors of negative 5. Negative 1, positive 5, and positive 1, negative 5. Those are my pairs of factors, okay? So is there one that adds up to be negative 4? Ah, yeah, there is, right? This one, that adds up to be negative 4. So I know that this factors to be using those pairs, or that pair. Okay, so, sorry, it got interrupted, so let's write it out. Okay, so 4u, and then I've got u minus 1 and u plus 5. There we go. We just factored it. All right, so let's take a look at this one. Let's decide, is there anything that we can factor out of this? So let's see here. We've got 3, we've got 22, and we've got 7. Well, the factors of 22 are 1, 22, and 11, and 2. So no, there's nothing that they all have in common for us to factor out. Okay, so let me show you something. This is truly my least favorite method for factoring. This is the way I was taught when I was in school. There was no AC method, which you don't know what I'm talking about whenever I say that yet, but you will. And so what we had to do whenever I was a kid is we did this. We truly just put a bunch of numbers in a bunch of places and we multiplied them out to see which one worked. And that's called trial and error. And I will tell you, it will teach you really fast how to factor, or it'll teach you really, really slow how to never get the answer right. And sometimes, even though you might be good at factoring, you may take up a lot of time to find this. And so that's why I don't like this method, but I am going to show it to you in case you ever have a professor that's like, just do this, blah, 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 blah. And you're like, what? All right, so what are the factors of 3y squared? Well, we can write that as 3y and y, or we can write it as y and 3y, right? What are the ways that we can write 7? Well, we can write it as 1 and 7, or we can write it as, let's see here, 7 and 1, right? Okay. And then since we have the y first and the 3y second here, we've got to write it this way as well. There we go. Okay. And I know that because both of these are pluses, that you have to have plus and plus and plus and plus and plus, and plus, and plus, and plus. All right, now, out of all of these, there's only one of them that will work, promise you, okay? So you have to multiply them all out to see which one works, because not all of these are the correct answer, okay? So 3y times y is 3y squared. Okay, 1 and 7. We got this part right. It's the middle term that messes with you, okay? So 1 and y and 3y and 7. Huh, look at that. We actually got it on our first try. This one is correct, okay? And actually, that means this one is too, because it really does not matter which order you multiply these in. But what I want to show you is why this one right here does not work, okay? So y times 3y, yes, is 3y squared. 1 times 3y is, and then also y times 7 is, and then you've got 1 times 7, which is 7. And then whenever you add these together, oops. So see, that does not give us our original problem. That's why this one is bad, and so is this one. Okay? So there was only, even though, but do you guys see that this and this are the same? It's just this one got written first over here. Okay? This and this are the exact same thing. All right? I don't want you to think that there are two different correct answers. There are not. This answer is the same answer as this one right here. All right, let's do another one, trial by error. Okay, so look at this. Now 6 can be written as 1 and 6 or 2 and 3, right? And then 5 can be written as 1 and 5 or 5 and 1, okay? So that's what I mean by trial and error is not fun. Like, also, I want you to notice too that this is a positive, right? But this is a negative. So that means both of these have to be negative, because a negative times a negative is a positive, but a negative plus a negative is a negative, right? So both of these have to be negative. All right, so let's multiply these out and see which one gives us the correct answer. B times 6b is 6b squared. B times negative 5 gives me a negative 5b. Negative 1 times 6 is a negative 6b. I can already tell you this one isn't going to work. And then negative 1 times negative 5 gives me a positive 5. But look, these guys add up to be negative 11. So it's not that one. Let's look at this one. 2b times 3b is 6b squared. Okay, so far so good. 2b times negative 1 is negative 2b. Negative 5 times 3b is negative 15b. Oh, this one isn't going to work either. Okay, so let's keep going. Let's try, let's see here, 1b and minus 5 and 6b minus 1. Let's try that, because this is different than this, right? Okay, let's multiply that out. So we've got 1b times 6b, which is 6b squared. We've got 1b times negative 1, which is negative b. Then we've got negative 5 times 6b is negative 30b. And look, these guys add up to be negative 31. So it's not that one either, or that one. Okay, so let's try 2b minus 1, which is different than that second one, and 3b minus 5. Let's do that. 2b times 3b, again, 6b squared. 2b times negative 5 is negative 10b. Or negative 1 times 3b is negative 3b. And then negative 1 times negative 5 is positive 5. Ah, there we go. This middle term now adds up to be negative 13. Okay, so this thing factors to be this right here. This is why I absolutely despise the trial and error method, because it's so easy to forget what you've tried. It's also very easy to accidentally write these in reverse order, and then you're coming up with the same answer and you're like, my gosh, I've done this 1,000 times. So I hate trial and error, okay? So I'm about to show you another way to do this problem that makes your life a lot easier. All right, you ready for this? Here it comes. All right, so again, the first thing you should do is ask yourself, can I pull anything out that they have in common? Is there a GCF? Well, there is for those two, but there's not for that one, right? So there is no GCF here. Now, if you'll remember from the last video, I told you over and over and over again to multiply the leading coefficient times the last term, okay? And so we're going to keep doing that, but in the last video, our leading coefficient was always 1, but in this video, it is not, okay? So in my calculator, I'm typing in 14 times -7 because I don't like to do math in my head. Oops. And I'm writing this off to the side, okay? Now, I want to come up with pairs of -98 that multiply to be -98, but I want them to add up to be -47, okay? I'm going to start with 1. So -1 and +98, those add up to be +97. That's not going to work. 1, -98, those add up to be -97. That's not going to work either. So -2 and 49, that adds up to be +47. Ooh, I think we're getting close. And 2 and -49. Ah, there we go. We found it. We don't even have to keep going. Okay, so we found the pair. And just so you know, there truly is only one pair that would work. So you could go ahead and write the rest of the factors, the pairs of factors for -98. But there will truly only be one pair that adds up to be that middle term if it is factorable. If it's not factorable, you won't even find a pair that'll work, okay? All right, so here's where things get different from the last video. So if you started tuning me out up to this point, you might want to wake back up and listen, okay? So from here, we can't just write this as x plus 2, x minus 49. Why not? Well, for one thing, because x times x is not 14x squared, okay? And 2 times -49 is not -7, okay? So we can't do that like we did in the last video. I'm sorry, I wish we could, but we can't. So here's what we have to do. We are definitely still going to use this pair right here. But now we have just another added step, okay? So here's what I want you to do. Write this down. Instead of writing -47x, we're now going to write that in 2 pieces. Guess what 2 pieces we're going to write it in? These two right here, okay? So I'm going to write plus 2x minus 49. I guess I should have probably drawn those lines just a little bit better. Okay, and now I'm just going to rewrite -7 at the end. Oh, don't forget your x there, okay? Now, check this out. I'm going to factor by grouping because we have more than 3 terms, okay? So I'm going to factor these 2 guys by grouping, and then I'm going to factor these 2, okay? So what do these 2 things have in common? They have a 2 and an x in common. What times 2x would give you 14x squared? 7 and x, okay? And what times 2x would give you a positive 2x? Plus 1, all right? Now, I told you this the other day in the last video or video before that if this is a minus, you write down a minus. If it's a plus, you write down a plus. It's a minus. So what do these 2 things have in common? They have a 7 in common. And what times -7 would give you negative 49x? That would be a positive 7x. And what times -7 would give you a -7? Plus 1, okay? Now, here's the kicker right here. If this right here does not match this exactly, then A, you've either factored incorrectly, Or B, this thing isn't factorable, okay? Which means it's prime, all right? But since it matches exactly, we're going to factor out the 7x plus 1s from both of these terms. So I got 7x plus 1 here. That got rid of that. And what am I left with? Look at that. We're done. We just factored it. Okay? Now, can you multiply this back out to see if you get the correct answer? Sure. 7x times 2x, 14x squared. Okay, that's good. 7x times negative 7x gives me a negative 49x. 1 times 2x gives me a positive 2x. And what is negative 49 and positive 2? Negative 47. Okay? And then 1 times negative 7 gives me negative 7. So at the very least, you should be doing the check your work in your head. All right. I hope that helps. All right. So I'm going to tell you right now that you might be looking at this going, ooh, I don't want to do 18 times 15. Well, neither do I, but I promise you I'd really rather not do trial and error on this. So we're going to do 18 times 15, okay? 18 times 15 is 270. And yes, this is a pain to have to write down all the pairs of factors. But like I said, I promise you this is easier than doing trial and error, okay? So, by the way, we know that if it multiplies to be a positive number but adds up to be a negative, that both of the factors have to be negative. And again, I'm going to just start at 1, and I'm doing this because I'll forget the only one that really matters if I don't start at 1. You can start wherever you want. You want to start by dividing by 5. That's totally fine. That's up to you. But I will always start with 1, okay? And if I find it, great. If I don't, then I know that it's not factorable and I don't have to worry about going back and trying to come up with the number that I missed, okay? So 270 divided by 2, 135. So nope, those add up to be negative 137. All right, let's go to negative 3. I should have known that. Negative 90. Nope, those add up to be negative 93. Let's see if 4 goes in. I don't think it does. Nope, it doesn't go in evenly. 270 divided by 5 is 54. Those add up to be negative 59. No, but we are getting closer. 270 divided by 6. Yep. And these add up to be negative 51. Again, getting closer. 270 divided by 7. Nope, that's a decimal. 270 divided by 8. Nope, 270 divided by 9. Ah, look at that. These add up to be negative 39. We are getting closer. All right. Oops, I forgot my negative on that. There we go. Let's look at 10. Look at that. We found it. That adds up to be your middle term. Okay, so again, rewrite the first term. Don't change it. Don't do anything to it. The middle term we're going to write using these two guys. And then just rewrite your last term, okay? Now we're going to factor by grouping, okay? So what can I pull out? What's our GCF on these two terms right here? It looks like 2 and n, okay? So what times 2n would give me 18n squared? 9n. What times 2n would give me negative 10n? Minus 5. Okay, and remember, since this is a minus, I'm going to write the minus here. And what do these two guys have in common? Looks like a 3. And what times negative 3 would give me negative 27n? Looks like a 9n. And what times negative 3 would give me a positive 15? Minus 5. Okay, so those two match perfectly. And I'm left with, I just factored that out, so I'm left with 2n minus 3. And that's it. We just factored it. Again, make sure you check your work. Multiply that back out. All right, let's look at this next one. Okay, so the first thing you should ask yourself is, do they have a GCF? And check this out, 10, 55, and 60. So I know that they're all divisible by 5, right? So we're going to pull out a 5, but check out your variables. I've got 4 y's here, 3 of them here, 2 here. So I can pull at least 2 out of all of them, right? So we're going to factor out 5y squared, okay? So what times 5y squared would give me 10y to the 4th? That's 2y squared. What times 5y squared would give me 55y to the 3rd plus 11y? And then what times 5y squared would give me 60y squared? And that would be plus 12, okay? So now let's see if this polynomial right here is factorable. Let's do 2 times 12, and we get positive 24 off to the side, okay? And we're going to write down all the pairs of factors for 24. So, and I know that because these are both pluses, I know that I'm only looking for the positives here. So 1, 24, 2, 12, 3, 8, 4, 6, and that's it. Okay, so the one that adds up to be 11 is going to be this one, okay? So again, this is your annoying little brother or sister that's going to follow you around to the very end. So we've got 5y squared, okay? And now I'm going to rewrite my first term. My middle term, I'm going to use these guys that we came up with. And then I rewrite my last term. Now, let's factor by grouping, okay? Again, the annoying brother or sister follows you around. And I'm going to factor out, what do these two guys have in common? They've got a y in common. So factor out a y. What times y would give you 2y squared? That's 2y. What times y would give you 3y plus 3? Okay, and remember, because this is a plus, I'm going to write down a plus here. And what do these two have in common? They have a 4 in common, so I'm going to factor out that GCF. What times 4 would give you 8y? 2y. And what times 4 would give you 12? Plus 3. And by the way, so this parenthesis goes with this one, right? This one goes with this one, but this one needs a closed parenthesis. That's why I would put an extra one at the end, just for the sake of closing it. Okay, now, annoying brother or sister, let's write that down. Now, we're going to factor out our 2y plus 3's, okay? And whenever I write it down once, that gets rid of it in both places. We're factoring it out, okay? So that goes away and that goes away. And what am I left with? Y plus 4. All right, we're done. We factored it. So I think it's kind of funny that at this point now they're saying, hey, use this AC method. Well, whenever I got tired of showing you the factor by trial and error method earlier, like what, 3 or 4 problems ago, I started using the AC method, okay? So that AC method, again, you want to look to see if you have anything in common, and in this problem we don't. So there is no GCF here. So let's go ahead and multiply our leading coefficient times your last term. So 6 times positive 2 gives us 12. And now let's write down our factors of 12, right? And because this is a plus, I'm looking for only the positives here. Okay, so 1 and 12, 2 and 6, 3 and 4. And there's only one that adds up to be 7, right? So let's write down our first term exactly. Our middle term turns into, and then write down your last term exactly. By the way, I've had people ask, is it okay to swap the order of these? And sometimes it helps you just because sometimes it helps to have a number that matches better with this one. And in this case, 3 matches just great, but 4 would too, so it really does not matter which order you write these down in. What will change though is the order of your factors at the end, okay? And remember how I keep telling you it doesn't matter what order you write your factors in, okay? Multiplication is the same whether it's 3 times 4 or 4 times 3, okay? So that's what would change, but it doesn't change your answer at all, okay? So what do these guys have in common? They've got a 3 and an x in common. What times 3x would give you 6x squared? That's 2x. What times 3x would give you 3x? And that's plus 1. This is a plus, so I'm going to write down a plus. What do these two terms have in common? They have 2 in common. Oops. What times 2 would give you 4x? 2x. And what times 2 would give you 2? And that's 1. Okay? So now we're going to factor out, because this matches that perfectly. That's what we wanted. Factor out your 2x plus 1. That means they both go away. And what are you left with? 3x plus 2. Ta-da! We're done. All right, let's look at this one. So there is no GCF to pull out of these. How do I know that? Because that's prime. So I know that unless I can pull a 17 out of that or that there's not much I can do. Okay? So what do we want to do? We want to take our leading coefficient times our our constant term. That's what that's called. So on my calculator, 8 times 21, and by the way, it's a negative 21. So I would write down negative 168. Okay? Now, I want the pairs of factors of negative 168 that add up to be negative 17. All right, again, you guys know how I roll with this. I'm going to write them all down, okay? Until I at least get to negative 17. But I'm going to start with 1 every single time. Now, take a look at this. This is minus, right? This is also minus. That means only one of these terms could be negative, okay? Now, here's the thing. Let me just show you with the first example, and then I'm not going to do it from there. Okay, so negative 1 and positive 168. So notice I've got the negative sign with my smaller number. Whenever I add these together, don't I get a positive number? Yes. Okay, so I really don't care that my smaller number is the negative number. What I care about is that my larger number is the negative number, okay? So that's why you're only going to see me write down the larger number as the negative, okay? Positive 1 and negative 168 gives us negative 167, which is kind of far from negative 17. Let's keep going. So I've got 2 and, what is that? Negative 84. That adds up to be negative 82. Nope, getting closer though. Let's see here. Do you know how to tell if something's divisible by 3? You add up your digits. 1 plus 6 is 7. 7 plus 8 is 15. So since 15 is a multiple of 3, I know that 3 will go in. So let's try 3 and negative 56. Those add up to be negative 53. No, getting closer. So 168 divided by 4. Yeah, that works. But let's see here. 4 and negative 42, those add up to be negative 38. Not quite. 5 doesn't go in. Let's try 6. Let's see here. 6 and negative 28, those add up to be negative 22. Getting closer. Let's try 7. 7 and 24. Negative 24, by the way. We found it. Look. It's this one. All right, so let's write our first term, not changing it all, just writing it. Our middle term, instead of writing negative 17u, we're going to write it using these two. By the way, this is what I was talking about earlier. Does it really matter if you write the 7 first or the negative 24 first? I tend to look at it, which one goes better with the 8. So the 7 doesn't go with the 8 as well, okay? So, but you can still write it there. It doesn't matter. You would then just only factor out a u, okay? Nonetheless, I'm going to put the negative 24 first just to show you it really does not matter which term you write first, okay? and then you rewrite your last term. All right, now we're going to factor by grouping. Okay, so what do these two terms have in common? They have an 8 and they have a u in common. So what times 8u would give you 8u squared? U. And what times 8u would give you negative 24u minus 3? Now, remember this is a plus, so we're going to write down plus. And what do these two terms have in common? They have a 7 in common. What times 7 would give you 7u? U. And what times 7 would give you negative 21? Minus 3. Okay? And notice this matches this perfectly. That's good. If it doesn't, remember you either A, factored incorrectly, or B, it doesn't factor. So now what are we left with? There we go. And it's factored now. All right, let's look at this one. So there is no GCF I can factor out. So let's multiply 2 times 5, and we get 10. So we're looking for factors of 10 that add up to be 6. And they both need to be positives. Do you see why they both need to be positives? Okay, so we've got 1 and 10 and 2 and 5, and I think that's it. And there isn't a one of them that adds up to be 6, is there? So what would we say here? What word do we use to indicate that it is not factorable? You would say it is prime, and that's okay. By the way, if it had a GCF, it would no longer be prime, but that's all you could possibly do is factor out the GCF, okay? But when you can't do anything to it, not a thing, the only thing they have in common is a 1, then it's called prime. All right, last example. Okay, so let's look at these. Is there a GCF? Yeah, they all end in either a 0 or a 5. That means that you can factor out a 5. Okay, so what times 5 would give you 10y squared? And that is 2y squared. What times 5 would give you a negative 55y? And then what times 5 would give you 70 plus 14. Okay, so now let's see if this is factorable. So 2 times 14 is 28. And I want it to multiply to be a positive, but I want it to add up to be a negative, right? So I'm only looking for the negatives here. So negative 1, negative 28, that adds up to be negative 29. Negative 2, negative 14, that adds up to be negative 16. 3 doesn't go in, negative 4, negative 7, that adds up to be negative 11. There we go, we found it. Okay, so we've got 5 out front, that's going to follow us around. 2y squared minus 4y minus 7y plus 14. Notice all I did was change the middle term to be the pair that we found. Okay, now let's factor this thing by grouping. I'm going to factor out the GCF between these two terms, which is 2 and y. What times 2y would give me 2y squared? Y. And what times 2y would give me a minus 4y? Minus 2. Now, since this is a minus right here, I write down a minus. What do these two terms have in common? They've got a 7 in common. And what times negative 7 would give me a negative 7y? Y. And what times a negative 7 would give me a plus or a positive 14? Minus 2. All right. Luckily, this matches this, so we can factor that out. The 5 stays out front. Don't forget that. You guys, whenever I was in school, I would forget that 5 out front every single time. And I got it wrong every single time. So make sure you don't lose the GCF from the very beginning, okay? So then we have y minus 2. I just factored that out of there. And I'm left with 2y minus 7. There we go. It's factored, and we're done. So this is tough and it takes some practice. So do yourself a favor and don't be hard on yourself. Just practice. Go over maybe some of these that I did in the video over and over again until it becomes second nature, until you're doing all the steps without really thinking. Okay? But be kind to yourself, and if you catch yourself getting too frustrated, walk away from this. Okay? Give yourself a break. You think better when your head is clear, not when you're angry or upset. All right. Have a good day.